Hello, today we're going to be talking about selecting and removing rows from our data frames. To do this, we're going to require a basic refresher on how to index rows in our data frames. This will allow us to select blocks and individually specified row numbers. If we wish to go beyond the user providing the specific row number, then we can provide R with conditional statements allowing us to select rows. This can be done using the function subset and the function filter from dplyr. Finally, we'll end with how you sample rows at random using the sample function. First, we're going to start by installing the ggplot2 package. This is just because it's got a nice interesting dataset called diamonds in it, which we're going to assign to a data frame called myData. Let's just look at the structure of this data quickly. Okay, so it's got 10 variables, and in terms of rows, it's almost got 54,000. So it's a big one. Just to confirm this output that we've got from the structure function, let's run the function nRows, and yes, just shy of 54,000 rows. The first thing we need to do if we're indexing a data frame is write that data frame's name followed by square brackets. Within these square brackets, the first value represents the rows specified and the second represents the columns. If either one of these is left blank, then we're selecting everything within that. So in this case, we're selecting the first row and all columns that are associated with row 1. So let's just print that to the console. And here's our new selected data. We don't just have to select rows one at a time. We can select whole blocks of rows. By using the colon, we can say we're interested in rows between 1 and 50. Once we've indexed to these first 50 rows with all columns, we can then assign it to a new variable. In this case, my.data.first50. We can then summarize, using the structure function again, the composition of this new data frame. It would be limiting if we could only look at certain blocks of rows, but by passing a vector to index for rows that we're interested in, we suddenly have a lot more flexibility. In this case, we're asking for rows 1, 3, 5, 7, and 9 with all columns. The benefit of using vectors in order to index rows is that you can use a combination of blocks and individual rows that you're interested in. So here we've created a new data frame with the first 5 rows of the previous data frame, then the 5 rows between 20 and 25, and then 2 other rows, 27 and 29. This indexing of data frames can also be achieved through the package dplyr. And whilst the code that I will show you next may not seem that effective and transparent because you're going to have to learn a new function and a new operator, I hope to convince you in later videos that this method of writing code can actually give very transparent and fast operating code. This complementary function, slice, enables us to look at the rows between 10 and 60. This line of code would typically be read, given my data, then let's slice the data for rows 10 to 60 and assign it to this new variable. If you wish to exclude rows, you can pass in the vector, and before that vector, add a negative sign. And this will select all the rows except for the rows between 1 and 50. We've now covered the basics of indexing, where the user can provide specific numbers to hone in on and select those rows, or even exclude them. Possibly a more interesting and dynamic way to approach selection of rows might be through providing R with certain conditions and selecting rows based on satisfying such a logical condition. There are many logical operators that we might choose to use here, such as less than, greater than, less than or equals, etc. And it would be worthwhile remembering these because you'll come across them again and again in R. Okay, so let's now introduce the subset function from base R, which allows us to divvy up our original data according to rows based on some condition that has been given. So here we have the subset function. The first input it takes is the original dataset that you're interested in. And then you give it a condition. In this case, x is the size in millimeters of the diamond, and it's one of the rows within my data. And we're asking to select rows where the x value is greater than 4. Maybe a more interesting approach to subsetting. Instead of using a random number that x is greater than 4 for classifying big diamonds, should be something based on the original data. So let's calculate a constant, which is the mean of diamond's volume. Here we multiply together x, y, and z values for each row, and we take the mean of it. So we have the mean volume for each row of data. And we've assigned this to a constant, mean.diamond.volume.millimeters cubed. And this gives us around about 130 millimeters cubed for the average diamond volume. Now we can take this constant and add it in to our subset function. We're now using the subset function on the original data, my data, and asking if a given row, if the volume of diamonds, millimeters cubed, is greater than the mean volume of diamonds that we've just previously calculated. And not surprisingly, if we look at the number of rows for this new subset of data, my.data.big.volume, it's half the size of the original 54,000 rows of data. And just for balance, because I've presented the base R subset function, I should maybe show how to perform this also using dplyr. Here we use a new function called filter, which is inherited from the package dplyr. And again, it takes the volume of a given row and asks if it's greater than the mean diamond volume. Okay, so we're now in the final steps of how to select rows from our data frames. Instead of having specific numbered rows that you're interested in, or certain conditions that you might want to reach, it's possible that you might be just interested in a random sample of rows. To do this, in base R, we can call the sample function. Here, I'm just introducing you to that function, where we've got sample, and we can pass it the number of rows of a given data frame. This first parameter that we pass to the function sample tells the length of number of rows of the data frame, in this case, around about 54,000, and it asks it to reproduce 20 random numbers anywhere between 1 and 54,000. And these are those numbers. We can call this function again with exactly the same call, and we'll get slightly different numbers, a different random sample. We can then take this vector and use it as an index when we try and call our data frame myData. So we have my data, we have the square brackets around it, so we're indexing values within it. For rows, we're interested in 20 random numbers sampled between 1 and 54,000, and we'll collect all the data for the columns. A dplyr equivalent to this is using the sample underscore n. Given my data on diamonds, then let's pass it to sample underscore n for 20 random samples, and the second condition here just ensures that we're not going to change the original dataset in any way, and that we're going to sample with replacement. Finally, the last function that I'm going to be introducing, that you're going to be introduced to today, is the sample_frac. Again, it's inherited from the dplyr package, and it allows you, instead of to specify an absolute number of rows you're interested in, it allows you to say the proportion or fraction of data that you want to be sampled. So in this case, 10%. So to conclude, this video has hopefully helped you learn how to index, to select and exclude rows from data frames, and how to write them to new data frames. We can perform selection of these columns based on conditions using logical statements, and even we can then sample at random rows and produce new data frames using functions like sample, sample_n, and sample_frac. If you found this video useful, it's likely that you'll be interested in some of our other materials on the RLab YouTube page.